Hello and welcome. Eulier Gonzalez here. Right now we're gonna look at this specific thing on the GitHub Actions when it comes to actually catching your GitHub Actions dependency and what are the strategies and techniques that we need to do. This is part of this UI. Oh my God, sorry. Jeez. This is part of the enterprise UI development. What does it mean? This, despite the fancy word that it is just a way of how can we now maintain code bases over a long period of time with a wide range of contributors in large teams. And for that, thanks to Steve Kinney, head front-end engineer at Temporal, and I get it why he holds that position, because if you need to provide now this solution and the ability to maintain, which is something that he briefly described that, that you can now add, change, migrate, or update dependency without the fear of breaking something. If you are responsible for that, there are some particular system that you need to put in place. And this is now what are the problems that we want to solve, and what are those systems, what are those different processes that we need to put in place as a way to work towards that goal. Particularly in the context of maintenance, here he described briefly is that similar to the pyramid of needs. So what are the things that we need as a way to make our code maintainable, especially with all of these different contributors over a wide range of people and backgrounds and in large teams. And this is something that it is valuable for a lot of company, because this is the way of how now can we organize ourselves, how can we now deal is with this complexity, the complexity of coordination. This is I'm gonna make a quick note here why this is so useful, this coordination, not only for others but also for ourselves. If we're able to coordinate, for example, similar as when you go out to, when you look at the Cirque du Soleil, all right, or some sort of place where they have now everything coordinated, Star Wars, Avengers, or any movie that they are beauty in those coordination, Black Swan. Okay, so the idea is that if you can do that to yourself, let's say you have now everything coordinated in a way that is hit the gym, eat healthy, take some break by going out to take a walk, or by meditating, and then now share with your colleagues and try to solve this particular problem. Take another break, learn and dedicate time to actually ponder all of these ideas as a way to solve your problems, and then you launch. If you have everything here, if you have all these coordinations, a lot of the time you're gonna get the outcomes much more faster. One, and second, then you're starting to realize that you are going to now be able to face more challenge, interesting challenge, better problems. So it means that if you have everything now structured in your day, coordinated in your day, then you can say, hey, let's go to now work in this more interesting and profitable problems that we need in our company, for example. Or now I have the time to actually explore these other areas across the world and takes note out of that, and see how they live. And but the idea here is that one of the things that capitalism actually promotes in ourselves is the ability to organize, to coordinate. I just want to bring that out here, because I think this is one of the main benefits of that, as a way to get the outcomes that we want. So in this case is make this code maintainability. That's why in this course we're gonna see how to lay out the infrastructure or these basic installations needed to guarantee that operations, in this case the maintainability, over a huge variety of contributors in large teams. And when you want to apply this, most of the time is when you need to migrate from one framework to another. That's one. Or you have inherited an older code base and they don't have anything this in place. There was a change in PM. Say, hey, now this particular POC that you create, now it turns out that this will be now a feature that we want to release. All right. And this is just an example of how you can now identify when you need to apply this, right? If you inherit these older code bases, or if you need to migrate to a new framework or whatever hot framework it is, or if you now creating as a new feature and then as a POC, and then that becomes now a part of the application, okay? A lot of the time, this is most of the use cases when you need to actually design this maintainability. So the way of doing that, okay, according to the experience of Steve Kinney, is that's going to identify is what are the needs that we need to as a way to now work toward that goal to maintain this. So first things first, we need to define is the infrastructure that will allow us to do that. The system here, which is testing. Again, this is for large company, which is testing, and also for startups as well. So testing, build systems, and some static analysis, right? Again, very narrow specific to this particular problem, which is building is now applications here, okay? And make it maintainable. And then on top of that, you're gonna define some sort of the process that allow you to do this, right? To make things much more easy to maintain. So here we have is now code review, branch protections, design documents, blueprints, all right? So anytime you are now in that particular process, okay, then you're gonna come out with some problems. So those problems that are recurrent now becomes a pattern, and as a way to come up with some sort of solution, we create now this particularly design patterns. So for example, that hey, this is the way of how we're gonna manage our states using is Redux. So this is now the particular architecture that we're gonna use, the Flux architecture, among other things that I'm not going to mention that they're not relevant for this. This is how we're gonna store. This is how we're gonna store and manage our data, and this is now how we're going is to deal with modularity when it comes to actually is make this code more testable, and we're gonna split this into abstractions, okay? Also, when it comes to actually is define the architecture of this application, let's gonna use now is a common file structure or an architecture, right? But this is now recurring problems that happens, and this is the typical solution that we use. So, because in this course, first things first, we started to look at the let me see, it's actually I can show you this exactly. This is the structure of this course, right? So far we are here, okay? We're gonna see now how can we implement these GitHub actions, and then how can we now see which optimization we can do, especially when we need to actually is run this test much more faster, because we don't want to actually we don't want to start from the scratch. That's the TLDR of all this, okay? So on top of that, because of that, right, Um, well, uh, the point of this is briefly describe this introduction, which is something that I already did. The basic of unit testing, which is understanding is the spectrum of the unit testing. You have unit, components, integration, and end to end. Some of them are so the closer the end to end, interesting. The closer the end to end tests, the more expensive it is, and that's what is the reason why we have, for example, is now replay browsers. As you can see, replay, exactly, replay, right? A time travel here. The first browser with instant replay, right? Which is a great thing. Quick start guide. Right, so the idea here is that makes all of those. This is quite interesting, bro. This is very, very interesting. Very, very interesting. Very, very, very interesting. Record your Cypress IO tests. Interesting. Replay dev tools, time travel, framework dev, browser dev tool. I get it. Live console logs, time travel. Okay. Exactly. So I go back to work on my machines and that kind of thing. So this is why solutions like this, GDPR, security and compliance. Interesting. This is why solutions like this. Sorry. Okay. I need to create a little bit more of work. Oh. Oh, that's not your view. All right. Interesting. Okay, that's interesting. That's a very good description and more technical there. Replies give me tools I need to solve seemingly impossible bugs. It is like the Redux dev tool, but for every line of code in your app. That's quite interesting. Very, very interesting. Very, very interesting. 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 So okay, so for example, tool like this, right? So now it makes much more or it is making now testing applications, for example, like this, and you got this. So now it's making this end-to-end less and less and less expensive, right? So for example, by using this kind of tools, but the TLDR is that this kind of tool right now, or this kind of test actually is now close to the end user, which is what we want. But the thing here is it is very expensive because you don't own any of the infrastructures in that. So that's why we have now in integration and component testing, and also with unit testing. Some of the common terminology that we're gonna use here in our unit testing, like it or test and test suites, which is just a fancy and pretentious way to say that this is a bunch of code that is gonna run. This is a bunch of code that is gonna run one after the another, and if one thing throws an error, they will notify you that. Okay. We also look at how we're going to write our particular test, and this particular test, how we use now is a test or it. You can also use this skip if, run if, fails, as a way to now write your particular test for these kind of companies. All right, this massive company that they need you to actually write this kind of test for that. It all start by writing is your own type of. It start by writing is your failing test, okay, and then write an implementation that pass that test. So then we look at what are the tools that we can use as a way to improve that our experience, and now the most likely tools or the most common method that we're gonna use to be close, to be equal. What are the subtle difference between them? Here we're talking about is referential equality and value equality. Value equality is actually checking if the property and the value is the same among this nested object, where referential equality is checking now if these objects have the same location in memory, right? If they are in the same space, if they're pointing to the same location in memory. To be close to, for example, to be close to for checking for numbers, instance of, to match objects, to contain as a way to check if this particular element is in this collection, in this array, and also is the expect.any. If you want to just, you don't care about the value, you just care about is the type. All right, and some also helper methods as a way to check is just a subset of key and values in that object, using object that contains or an array contain, right? So after we look now, how can we define is our setups, which is the way of how can we now create is our tests by having is the by putting it everything at a glance, one, and then you define your setup test, the testing logic, and ultimately is the assertion, right? So great, because then we also look at how can we deal for a advanced topic or advanced techniques when it comes to actually dealing with asynchronicity or dealing with this concurrency, right? You can use the async and await as a way to now use this particular pattern to help you to write your code that look like synchronous, but the reality here is that it is using some of the built-in JavaScript tool as a way to handle that, right? and that is using promise behind the scenes and also recognize some of the inversion control. Again, things that go beyond the scope of today's video. But this is one of the things that we can use, right? The same for spec any, spec reject as a way to check if that we receive a roundly response, all right? And when it comes to actually dealing with timers or any elements on the UI that appears and after an X amount of time disappear, this is when you can start to deal with timer as well as date, right? And how you can actually how you can make that happen, how you can work with that, right? So with that, right, this is now the particular patterns of when you're working with timers. And another tip is for bug reports, you know. Again, all of these are patterns that are repeated, and then you come up with some sort of solution. That's a way to understand that. So far so good, right? So far so good. So building a CI pipeline with GitHub Actions. So now that we know how to write our code, the setup and the kind of things, then we need to actually lay out the foundations to make those tests run in some sort of environments automatically every time we want this to contribute or we want to add some code to our repo, right? So because of that, we have now this particular thing called CI and CD, which is a practice, a discipline, all right, of how you want is to integrate your code with a lot of contributor using now Git as well. So that's when you have now this Git branching solution. Something that, again, you go beyond the scope of this. We're assuming that you at least are quite familiar with Git, all right? And this is now this particular practice of how we can now integrate codes to that, right? So in the code integration, you're going to now is automate the process of once you do that, when you add those changes, you automate, you run your you build you build the application, you run the test, and if everything went well, you generate an artifact that contains this new change that after some sort of code review, some sort of thing that we're gonna see later. So after that particular code work as expected, then you're gonna pass that to the staging environment or this component of the continuous delivery. What you wanna now is to run the test here, the staging here, okay, as well as run the staging, okay, run the staging. This staging is run the staging environment. Sorry, this staging environment actually can have access to production data, or it is close to production data. So we're gonna run that this change actually works as expected and don't break anything in our code. If that it is, then we go now to consider that we're going to consider that to a release candidate, right? An RC. So this release candidate, well, after you define that, you can deploy that to production, right? And not only that, that's not the end, because then you need to operate on those changes. Is that actually works as expected, all right? And then monitor your application. All right, so because of that, GitHub Actions actually allows that particular process, especially of the continuous integration, much more easy, right? So it provides now a file with this particular format using YAML file that will allow us is to define is workflows, which is now a series of jobs that will be run, can be one or a series of jobs that will be run that you define on your GitHub under the .github/workflow file anytime an event happens. This can be an list of event that is coming from GitHub, that's one, or schedules you define. Then hey, after us, you delegate that using the Chrome format, or when you want to trigger is webhooking other components, or in other words, posting to an external API, right? Which means you want to now trigger is, let's say, when you integrate this code, all right, and when you pass. So when you're integrating this code, and when those codes actually change in development, you want to now trigger is a workflow in the Stripe development environment as a way to see that everything works as expected. That can be one way, one example. So, so this is now talking about the events, and when this event happens, you're going to trigger now a job. So these jobs can, by default, runs in parallel, which is a series of steps or actions, series of steps that run on the same runner. So this series of steps, which is bash script or actions, and actions can be is reusable GitHub, reusable custom GitHub code for repetitive and complex tasks. So for example, pulling the repo into this server, or setting the build tool for your build environment, all right, or for your dev environment. A good example of this is when you are developing is React Native applications. A lot of the time there is a lot of things that you need to do only to make this works on development. So first thing first, you need to have an OS, and that OS must have several dependency installed. So for example, Android Studio or Xcode, and similar for Cocoa, and some of the Android SDK, and then when you need to actually set up the no environment as a way to now allow you to use React Native, also the dependencies that this application need in nodes, and then it's when you can now actually is starting to develop your application. There's a ton of S things that happen there. A lot. But again, it's very, very, very interesting to describe, not to pass through that. So that's why there are some actions that automate that particular process. And also, for example, when authenticating to a third-party vendor, right? Let's say AWS, Google Cloud Runs, Azure, right? So this is what these things can allow you to do. And because these particular jobs or these steps that are now, or these actions or this bash script where it runs on the same runner, okay? This runner is just a server that provides you, is a virtual machine that is a newly fresh virtual machine provided you by GitHub as a way as a way for you to run all of your jobs per virtual machine, right? So each one of your jobs that you're executing, the GitHub Actions provide you a virtual machine to run that. So you can also have now concatenate its jobs, no problem. But by default, this is what you're going to have. We also look at how can we now start to create our GitHub Actions for a simple test, which is test, then how we can do it for build, and slowly but progressive, how by defining all of these steps and using the actions, how easy it is to actually run our tests. But if you can imagine, right, you need then some sort of protection, because anytime that anybody that can now integrate code, you want to have some sort of guidelines, some sort of guards here. And this is when we need to talk about security, a world of security, because this branching protections is something that is must follow the trust guidelines, the trust and security guidelines based on your company. So a decent sized company, right, will need to follow is this particular compliance policies, right? So for example, SOC, that it comes from the American Institute of Certified Public Accountant, okay? That say, hey, whoever is actually adding the code to this, we want to make sure that you are doing that in the benefit of the consumer. You know, please. And the other is now in terms of how now organizations should deal with quality as well as the security. That's why, for example, some companies are following is the ISO standards. So, for example, the quality management systems, which is the ISO 9001, all right, that focuses on what is the quality that focuses on customer satisfaction, how to achieve this customer satisfactions, and develop process that improve the business continuous innovation and improvement, right? Again, this go beyond the scope of this, but the point of that set of requirements, this is not a framework, it's a set of requirements that tells them, hey, this is the thing that we need to actually follow as a way to guarantee, first, quality and the output, right? Second is that the data that we're storing here is confidential, is integral, and it can be accessible. Among us, is not repudiable. So this is now some of these principles that, for example, in information security management systems, or ISMS, from this standard, the ISO 14, the ISO 20, the ISO EAC, ISC, Jesus, the ISO, the ISO ISC, I think it is, ISO ISC, exactly, ISO IEC, right? So the ISO IEC 27001 is all about, right? Its focus is on this information security management systems. Again, some set of requirements that this kind of application must follow, which is confidentiality, integrity, and accessibility or availability in this case. So we're just describing is now the quality process as well as the security, and what are the models that now companies are applying in their daily life. Because back in the old days, there is something known as the castle and moat, where all of the company resources are focusing on the firewall, or to prevent that someone actually get into the castle. All right, so now they have these firewalls or identify prevention systems, identify prevention systems, and intrusion detection system, and all that kind of thing, but as a way to prevent access, right? I'm gonna take us this quick segue here. Yeah, I'm gonna take this quick segue here when it comes to talk in terms of the things about the security and how now Moxley Marlin Spike, right? And how Moxley Marlin Spike mentioned that has been a losing strategy. So now the encryption is the right approach when it comes to provide security to companies. One of the trade-offs is that if you are not able to, for some reason or remember the key or as a way to decrypt that data, so your data can be lost. Even though right now there are some efforts for companies, even in China as well, to make this to push forward in terms of the how do you put it? To push forward in terms of how you can now is figuring out the keys quickly as a way to decrypt that and have access to this data. And this is now the quantum computing, and that's one of the main applications of this. But in any case, the idea here is that we want to know each other dirty pants. Yeah. So that's why we talk now. If we come back to this, that's why we talk now on the security models. And security models like the zero trust policy is say, hey, if you want to have access to a resource, this is how and when you're gonna do that. And the whole point of this is to first continuous monitoring, which is one of the principles of this continuous monitoring, similar to the device monitoring, who can have access to this, as well as the principle of least privilege, which is something that you want to implement now, especially in your application, in your code bases, right? So for example, is the ability that only small chunk of people, including the CEO, can actually do harm to this code. In this case, can actually push code to this, or if they want to now merge some of this code, they can do that. This is the authorized person to do certain things. But the whole point of this is to make them provide the least minimal privilege in your systems. And also when it comes to an attacker can have access to your system, prevent lateral movement, which means that they cannot jump through one network to another or one computer to another, right? So by putting all of this zero trust policy here, it's like, hey, who are you? You want to check is this, as well as some sort of token that you must provide when you are getting into this. And those set of tokens are this multi-factor authentication, right? So things that we say, hey, so things that we say, hey, we want to verify who are you, who really are you. Information security manager. It's also here is this. This is the from quality here as well. This is compliant policies. The QMS. QMS, right? Which is ISO 9001, which is QMS, right? QMS for that. ISO 9001 QMS. What? Mm-hmm. Mm-hmm. I think we can have access to the newer format. What French stuff is? Oh, but this is. No, I want just the overview of this. Exactly, QMS. Okay, QMS. Okay. Exactly, the QMS, and then some other compliance that companies now need to actually make sure and guarantee that kind of thing, right? So, for example, the ISMS is one of them, the Cloud Security Alliance. The other is the payment credit or payment card industry data security standard. That's very sensitive. That's very, very, very sensitive. Geo-specific, HIPAA, EBA, and BAN, and well, talking about is a security model here as a zero trust, right? So this zero trust, which was now coined in 2010 as a way to now find a way to solve this zero trust or this castle and moat, where they were easy to now steal credentials when they get access to, steal credentials, get malware, perform some social engineering attacks. It was not good. It was not beautiful, by the way. No. Exactly. So, so this is now part of the core of SASE, right? So now this is part of the core of SASE. You might wonder, what in the F is SASE? Well, SASE is now a way of how you can build network, that a way you can build, it's a model to build is network connectivity and network security, right? Interesting. So the idea of find a way to build this network connectivity and network security, all right, is because the increasing in demand of a lot of these companies to host their research on these cloud providers. That I don't know, you shouldn't do that, but in any case, you will find that out. But as the company now pushing all of this research, business assets in those cloud providers, okay, and the rise of distributed workforce that can be much more effective at a distance, the SASE, which is now the service, the security access service edge, this way of, or this model of how we can now build network connectivity and network security. Okay, so how you can have access to this resource and how we can preserve that. Okay. So SASE, it is originally like that. So listed zero trust as core of the component as a secure access service edge. So this particular model here of the zero trust security model, okay, makes a lot of sense. So this zero trust security model, all right, very interesting. So this interesting. This secure access this zero trust security model, which is now the way of how now this is now the core component of this SASE. And I don't mean that sassiness, okay? So SASE is this secure access, secure access service edge. And this is as a response of company now putting all of these assets to be managed by all of these cloud providers. And I get it. Okay, I get it what they're doing that. I get it why they're putting all of these resources to be managed for all of these cloud providers. Because at the end of the day, we are going to organize our resource when we are going to handle our we're gonna coordinate our efforts to whoever can do that in the most effective way to get the outcomes that we want. There is a huge okay. There is okay. Okay. This is also part of the economy here. Anyway, but that's the reason why we are now companies are putting all of their business assets in all of these companies on the cloud. All right. So they need to find a way, especially for this company, on how you can secure the access of this resource. So service access secure edge or the secure access service edge. That's what it stands for. It's secure access service edge. So because of that, because it is quite convenient to put all of the business assets on those cloud providers, because they are now much more better when it comes to actually manage all of this resource. Okay, I can accept that. And we have become much more effective as a workforce to do that, to manage that. So now zero trust policy has become zero trust policy has become now the core of this, and this is now on the edge network. So SASE platform combined network as a service by implementing technology by like this. Again, this is now a particular model of how you came. It's an architectural model. When I switch that word, it's an architectural model for network security, or that combined network security and network connectivity. And the reason is for that. So SASE platform combines its network as a service by implementing is one of these core principles: zero trust policy, secure web gateway, cloud access security broker, cloud access security broker, secure. Okay, because as they're providing is the zero trust policy, secure web gateway, cloud access security brokers, software defined one or one as a service. Okay, interesting. Software defined one or one as a service, and next generation of firewall. Okay. But remember that at the end of the day is that this is an architectural model that combined is the network security and network connectivity. Why is that? Because the vast majority of companies are now putting all of these business assets in those server cloud providers because it's very compelling. So they need to actually create a way of how they can secure that and provide connectivity to the workforce that allows them to actually improve their business for this company, and also to secure that. So that's why we have the SASE here, the secure access, the secure access service edge, right? They're gonna access it to this computer for that. And now part of the core component of this architecture, interesting. God damn it, bro. Got French toast there. And this part of this infrastructure of this part of this component, all right, is zero trust policy, secure web gateway, cloud access security broker. Cloud access security broker, and they're going to implement now a broker to actually see is it gonna allow them to access or not. Cloud access security broker, software defined one or one as a service, that hey, which kind of application can be run per network. Holy crap. NextGen Firewall, zero trust model, as the name suggests. Trust no one externally or internally, and it is used by this. This is very, very, very interesting. Oh, the other is microsegmentation. Oh, crap. Jesus, French toast. Holy moly, this is the components of this. And what are the key benefits of SASE? Reduce risk through zero trust policy, reduce cost through platform consolidation, operational efficiency and agility, improve user experience by hybrid work. What are the common SaaS use cases? Augmenting or replacing VPNs to modernize secure access. Augmenting or replacing VPN for modernized secure access. Interesting, of course, because now you don't need to run this virtual machine. You just need to run this a program that allows you to now have access to this edge in a secure way. So instead of actually having to access through their core business, which may be far, far away, now you're gonna have access to this instance. Simplify contractor third-party access. Secure Access Service Edge extends secure access beyond internal employee to third-party like contractor partners or other temporary or independent workers. With resource-based access, hey, organizations mitigate the risk of over-provisioning contractors. Threat defense for distributed office and remote works. SASE allows organizations to apply consistent IT security policy across all users, irrespectively of their location, by filtering and inspecting all outgoing and incoming network request traffic. Malware-based attacks, multi-channel phishing, attacks that span multiple communication channels, inside threats, data exfiltration, and more. Data protection for regulatory compliance. Because SaaS provide visibility over every network request, organization can apply policy to data in each request. Simplify branch connectivity. Simplify branch connectivity. A SaaS architecture can help augment it to replace a patchwork of multi-protocol label switching, circuit, and network appliance to more easily. How SASE and SSE, Security Service Edge, are different. In other words, SASE incorporates a user secure access as part of the network architecture. It is worth noting here that industry analyst firm Forrester categorize the SaaS model as Zero Trust or CTA. This is the name of the company, by the way. Exactly. This is the name of a company in China, by the way. Now, I don't know what will happen with that, but Latam actually were one of the main consumers for this. Yeah. Latam were one of the main consumers of this. Exactly. A lot of people in the US barely know about this. They barely know about this. They barely know about this smartphone. Only this one? Series A? Interesting. The Series V. The Series A? The Series V. Interesting. CTE, similar to Huawei. And Huawei, well, they made up their own particular problem. Okay. All right, fellas. Okay. Interesting. They don't sell nothing here. That's interesting. Oh my God, the Chinese people are actually great at copying things. Yep. They're actually great at copying things, but when it comes to innovate, it's because innovation is not easy, bro. It requires you. It requires you to be in a war state, like. Anyway, that's right. SASE, right? CDA. Not all organizations have a cohesive approach across IT. Additionally, while most SaaS platforms include core capabilities, noted early, some include additional SSA capabilities such as remote browser isolation. Applies to zero trust principles to web browsing by assuming no website code should be trusted to run by default. RIB load web page and executes any associated code in the cloud away from the user's local device. This operation helps prevent malware download, minimize the risk of zero-dawn browser vulnerability, and defense against other browser-borne threats. Data loss prevention. To prevent data from being stolen or destroyed without permission, DLP technologies detect the presence of sensitive data in web, SaaS, and private applications. In combination with SWG, DLP solutions can scan data in transit. In combination with CASB, DLP solution can scan data at rest. Detailed experience monitoring. How Cloudflare's enable SASE. Cloudflare's One Service, which include all aspects of SASE, are designed to run across all Cloudflare networks locations. But this is now a frame. It's an architecture. Anytime we talk about an architecture, it's a way of how you can build things. Period. In other words, we can actually is this. So it is safe to assume that any time we read architecture, it can be translated to a way to build something. It's quite insightful. Indeed, architecture encompasses much more than just an aesthetic aspect of building. It's a comprehensive framework for creating functional safe like that. What the fuck? Your observation about architecture is quite insightful. Indeed, architecture encompasses much more than just aesthetic aspect of building. It's let me actually ask now too, because I don't know which model actually is answered to me. ChatGPT, right? ChatGPT, right? Yeah, that's a safe and insightful assumption. Architecture often refers to a structured way of building and organizing something. So this is a particular way of how can we now build something based on a particular problem. That's all. Just not in the physical building exactly, but also in various other fields. Okay. So anytime we talk about architecture, we talk about is a way of how we can build things. Can be physical, can be abstract, for a particular goal. Makes a lot of sense. So simplify, bro. Simplify. So this is an architecture. Interesting. It's an architecture. Exactly. Software architecture refers how software components are structured in an interact. Organizational architecture, network architecture, blah 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 blah. Interesting. Holy crap. And you can also be the architecture of your own life. Here we go. Oh, crap. Here we go. Okay, but this is now the component that is made of this. SASE platform typically include the following technologies. Okay, the following techniques for that. What capability does SASE offer? SASE deliver network service that simplify connectivity, security service, and operational service and policy engine. I didn't expect that to dive deep too much into SASE, but I think it worthwhile to actually be able to understand this before now understanding is this catching mechanism, that kind of thing. All of this is just as a way to have much more understanding of what are the things that we're doing, bro. Yep, it is, bro. Okay. Holy crap. So that'll be all for this video. Take care. Bye bye.